Hi, welcome you all to the YouTube channel of DCC NIT. This is Mayur, and today I am going to discuss the problem C2 dual, the hard question that came in Codeforces round 889 division 2. This will also be the solution for the easy version, that is C1 dual, because the only difference between them is the constraints. So let's take a look at the problem statement. The problem states that we will be given an array of integers which might have positive, negative as well as zero. Now we can perform the following operation, that is, we can add any two integers ai and aj and set ai to that value. Now we have to make the array non-decreasing in at most certain operations. Whereas in the easy version, it is like we are given an upper limit of 50 operations. That is the only difference. Everything is same. So if we take a look at the test constraints, so t is less than equal to 500. The length of array is between 1 to 20, and the numbers are between minus 20 to plus 20. So let's take a look at the examples. Here, the first example is 2, 1, 2, and 1. So, what we can do is like I can add 2 to this one, so it will become 2, 3, and this is a non decreasing array. The next example is 1, 2, minus 10, 3. So, what I can do is like I can add 3 to itself, so it will become 6, then 6 to itself, it will become 12. Now, if I add 12 to minus 10, so it will become 1, 2, 2, and 12, which is again a non-decreasing array. So that is those are some of the examples. Now, how to proceed with it? How to do it? For this, there is the predefined algorithm. It is like you could do it based on some observations. You will try a lot of methods, see which one works, which one doesn't work, and like that. From those observations, you will deduce what is the correct solution. Now, so while making such observations, it is always important to remember that we'll first start off with some basic things. Means, we won't take any random array of positive, negative, zero integers, means a mixture kind of array, and try to observe the solution of that. This is not feasible because this is quite a complex one. So what we will do is like we'll take some easy examples initially. So what if all the integers are positive? Let's say we are given an array like this: 5, 2, 8, 9, 4, 6. So this is the array. Now, what you can think is like here 2 is smaller than 5, so 2 must be increased. Then you might think of adding 8 to 2, so it will become 10. Again, 8 is smaller than 10, and so you will add something to 8, let's say 4, so it will become 14. Or sorry, 12. And like this, you can go on like this, but you can try a lot of methods like this, but probably they might give a correct solution as well as a wrong solution too. So here, what I'm going to do is that we'll have to observe something. So what if we do the prefix sum of the whole array? Shouldn't that work? If we do the prefix sum of this array, so the first number will be 2, the next number will be 7, the next number will be 15, then it is 26, then it is 26 plus 4, 30, and lastly it is 36. So I've done the prefix sum, that is adding all the elements up to that number. Like 5 plus 2 is 7, then 7 plus 8 is 15, 15 plus 9 is 26, 26 plus 4 is 30, 30 plus 6 is 36. So this is an increasing array, right? That's the solution. If we are given a array of zero positive integers, that is there are no negative integers. So this is case 1. When there are no negative integers. The next case is, let's say if we are given an array which doesn't contain any positive integers. Let's say if I take the same array in negative form: minus 5, minus 2, minus 8, um, minus 8, minus 9, minus 4, and minus 6. So from the previous example, now you can think of like prefix sum won't work here, because prefix sum, what will happen in prefix sum? It will be minus 5, then minus 7, then minus 15. This is a non-increasing array, not a not decreasing array. So instead, we have to do suffix sum here. So if we do suffix sum here, it is minus 6, then minus 6 plus minus 4, it is minus 10. Then minus 10 minus 9, it is minus 19. Then minus 27. Then minus 29 and minus 34. So you can see it is a non-decreasing array. So thus we got our solution for when there are no positive integers too. That is, it contains only zero negative integers. Let's say if there is zero somewhere here, so it is again minus 34, right? So no issues. It again contains zero too. Now the next thing is, now let's take a look at the complex one. If there is a mixture of positive and negative integers and zero too, so what will we do? Now what we can think of is like, our first goal is to make the whole array to either positive integers or to negative integers, and then we can continue from this step 1 and step 2, right? If this is means if we somehow can convert all the whole array into a positive array, then we will follow step 1. If the whole array becomes negative, then we will follow step 2, right? So that is the thing. That is our primary goal. Is what is that? We'll first convert the whole array into either positive integers or negative integers. Means zero positive integers or zero negative integers. So for that, in total we are given 31 operations. 31 operations. Now let's take a look at another thing. Suppose the array is already positive or negative. Now since the whole array contains 20 integers in the worst case, so how many operations will it take to make it non-decreasing? Suppose the whole array is positive or negative. Let's say in step 1, there were 6 integers, right? For 6 integers, we required 5 operations. Like I had to add 5 to 2, then 7 to 8, then 15 to 9, and so on. So we required 5 operations when there are 6 integers. And in the worst case, we know that there can be 20 integers at max in the whole array. So at max, we will need 19 operations for this prefix sum or suffix sum method. So remaining we have only 12 operations. So our task is to make the array totally positive or totally negative in 12 operations. That is the thing. I took this in the worst case scenario. Now for smaller size for smaller sized arrays, more operations might be available because it won't take 19 operations there. It might take 10, 12, 13, whatever. But I've taken the worst case. Now there are 12 operations, right? So we'll again take a look at some example and see what happens there. Now let's take another look at an array, which is like 5, uh, 5, 2, then minus 7, then um, minus 4, minus 10, 16, minus 5. Okay. So here there are 4 negative integers and 3 positive integers. What I can do is like, I can add my this 16, this is the maximum number here. Like if I take the absolute value in any cases, 16 is the max possible value, numerical value. So what I'll do is like, I'll add 16 to all the negative integers. So it will be 5, 2, then it will be 9, then 12, 6, 16, and 11. So all of them are positive integers, and we could convert them in 4 steps, and then it will take 6 more steps to make it non-decreasing. So in total, 10 steps are required. So that is the thing. What we'll do is like, we'll first find out which is the number, which is the maximum possible value. Then we'll add it to the opposite side. Means if this maximum possible value, that is 16, it is on the positive side, right? Here 16 is in the positive side, and what we'll do in that case, we'll change all the negatives to positive by adding 16 to them, because we know that whenever we add 16 to any negative numbers, those negative numbers are smaller because 16 is the max possible number. So all the negative numbers will of course become 0 or positive, right? So the whole area will become positive. Now the reverse case, let's say if we are given minus 5, minus 2, then 7, 4, 10, minus 16. Uh, Here you can see that the maximum possible value, that is 16, it is in the negative side. Then what we'll do? We'll change all the positives to negative, correct? Because we know that whenever we add minus 16 to any of the positive numbers, it will of course become negative or 0, because here this is the maximum possible absolute value. So it will become minus 5, minus 2. Then for 7, I will add minus 16, it will become minus 9, then minus 12, then minus 6, minus 16, and it will become minus 11. So it is again, the whole array has become negative. This is one. So that is the thing. Now, the constant here is that, let's say I have an array which has 19 negative integers, 19 negative integers, and one positive. And this is the largest value. Let's say it is 20, and here all are between minus, means it can be any value, like between minus 19 to minus 1 or 0. Say here in this set, in case of 19 negative integers, let's say those values are from minus 19 to 0, and the only positive number, that is 20, that is 20. So here we know that 20 is the largest absolute value, and by the previous logic, we would have said that we'll add 20 to each of the negatives to make the whole array positive. But there's a catch. Here we take 19 operations to make it positive, correct? Because there are 19 negative integers. So initially 19, then again 19. So it will be 38 operations, which is exceeding our limit of 31. So this is not possible. What can we do in that case? So we know that since there are 12 operations in hand, means we had 12 operations remaining. So if the count of the opposite side is less than equal to 12, let's say among 20 integers or whatever, let's say if there is even an array of 18 integers, let's say there were 12 negative integers, and let's say there are 5 positive integers, and here absolute of positive side, it is greater than absolute of negative side. Let's say positive has a value called 16, and negative has values in the range minus 3 to minus 12 only. So 16 is of course greater than the absolute value of any of the numbers in the negative side. So what we can do is, like, we can transform all the negative to positive. And since there are 12 negative numbers, we can of course do that in 12 operations. Then we will use our remaining 19 operations to make the whole array positive. So that is done. Means if there are 12 integers of the opposite side, that is the one which is smaller absolute value. The negative number has a smaller absolute value. That is, its maximum absolute value is 12. So the side having smaller absolute value, if the count of that is less than equal to 12, that is done. We can do it easily. We'll just check it and do it. But what if the number is greater than 12? That is, the count is 13 or more. Let's say there are 13 in the old scale, there are 13 negative integers and 7 positive integers. This is the case. Now, if suppose the negative numbers has the highest absolute value, let's say minus 18, this is the highest absolute value, and the positive set contains numbers between 3 to 10, let's say. So here, of course, minus 18, it is the highest absolute value, and we can add minus 18 to all the positive numbers to make them negative. This is done, but that is not the case I'm talking. Here I'm talking about the case that what if the positive side contains the highest absolute value, that is 18, and negative side contains numbers between minus 2 to minus 10, let's say. Now, here the issue is that I can't add 18 to all of these numbers to make them positive, because it will take 13 operations since there are 13 negatives, and then 19 more operations to make the whole array non-decreasing. So instead, what I will do is that if this is the case where there are like 13 or more numbers in the opposite side, or in the like side that has smaller absolute value, I will take the largest number among them, let's say minus 10, and I will just multiply it by 2, or like add it to itself. So minus 10 will become minus 20 in the next step. So in just one step, it has become minus 20, and now this is I'm sure that this will be the largest because we know that the array contains integers between -20 to +20. So we know that there are no numbers that will be greater than 20 in the means if we take only the absolute value, then there will be no number that is greater than 20. So if I add -20 to all the positive integers, they will either become negative or zero, negative or zero. That is the thing. So the whole array will become negative or zero, and again will that will give us the array required in step 2 or type 2. So what we have done here is like we have taken the largest possible value in the negative range and we have just multiplied it or like added it to itself until we get the number greater than equal to -20. Let's say if it had been the negative numbers only contained integers in the range -1, -1 only. Let's say -1 to -1. Means all the negative numbers are -1. Fine. And the positive numbers had numbers only 1. So what we could have done is like we could have changed -1 to -2 in one step, then -4, -8. That is where adding it to itself, -8 plus -16, then -32. So in just 5 steps, it has been changed to -32. Then we will add -32 all the 7 positive numbers. So 5 steps plus 7 steps, 12 steps, and then 19 more steps. So it will be 31, which is in our given constraint. And we know that even the smallest number, means smallest absolute value, that's -1, it will take 5 steps only to become -32, that will cross the range of -20. So in the old case, this is the thing. Even we have this kind of range, then in 5 steps, we'll change it to a bigger value, and then we'll change the opposite side. Here, we'll change all the positives to negative. That is the thing. So I know there has been a lot of cases, so we'll take you through the code to get a better understanding of it. So here initially I have just declared these variables positive, negative, zero. That is count of positives, count of negatives, count of zeros. Then max pos means what is the maximum positive number? Because I needed that to compare whether positive side has the max absolute value or negative side has the max absolute value. Then minimum negative, there is the minimum negative number, which will give the max absolute value. Then max pos IDX, that is the index of the maximum positive number. Then min neg IDX, that is the index of the minimum negative number. Here, this one will store the result. Fine. So, just a minute. Yeah. Now, while I'm taking the array as input, I have checked whether it is a positive number. So, positive plus plus. Just a minute. Oh. So, whenever I check for positive numbers, like if array I is greater than 0, so positive plus plus. Oh, there has been some issue. Okay, fine. So positive plus plus, then I'm checking whether it is even greater than max positive. So in that case, I'm assigning it and changing the max positive to. Same is for negative and lastly for zero. Then we are seeing whether if suppose there is no negative integers, that is the array only contains positive integers and zero. In that case, we'll just do a prefix sum that is being done here. You can see here, this is a thing. Then, sorry, not this one. Then if the array doesn't contain any positive integers, that is it contains only negative integers and zero. So we are doing suffix sum here. Now the next case is if there are positive integers, the count of positive integers is greater than or equal to 13. In that case, what we will have to do means we are sure that we can't change all the positives to negative. The only thing we can do is like we can take one number from the positive side and add it to itself until it becomes a bigger value and then change the negatives. So that is the thing. Here we're taking, means we're finding the index which has the highest value, that is max positive index, and we're adding it to itself, that is we're multiplying it by 2 until it becomes greater than or equal to 20. Then we're changing all the negatives, that is if array I is less than 0, then we're changing all the negatives to positives by adding that maximum value. And lastly, we're doing prefix sum. Similarly, for the negative case, if the count of negative is greater than or equal to 13, then we're finding the value which is the max absolute value. That is mean negative IDX has the value which has the maximum absolute value. So while it is still greater than minus 20, we are just adding it by itself. So we are multiplying, that is we are multiplying it by 2. So here at after some steps, that is in the worst case after 5 steps, it will become lesser than equal to minus 22. And then we'll change all the positives to negatives using this number. Then we'll do suffix sum. This is the case. Now the remaining case is that if positive numbers are, means if both of them are count of both of them are less than equal to 12. In that case, we can just flip the other side, which is lesser absolute value, like that. So here, if maximum positive, this value is greater than absolute value of mean negative, that is minus of mean negative, then we'll change all the negatives to positives. So here it is done, and we're doing prefix sum. And lastly, if the other case is here, like the negative side has the higher absolute value. The negative side has the higher absolute value. Let's say minus 18. Okay, minus 18, and the positive side has numbers between 2 to 7. So negative side has a higher absolute value. So what we will do, we'll change all the positives to negatives, and we can do it because there can be at max 12 occurrences of positive sides. Because if there have been 13 or more occurrences, we have checked that case in the previous if else conditions. So we'll change all the positives to negatives, and then we'll do suffix sum. Lastly, we'll print the result. So that is okay. I know this is quite long and pretty confusing. It will be better if you do a dry run and check all the cases by yourself. There were 6 cases. The cases were like one, were all non-negative, non-negative. The next case were all non-positive. The next case were where positive, count of positive is greater than equal to 13. So in that case, we have to take one number from the positive side, and means you can take any number though. We don't have to explicitly take the highest number, because we know that even if we take the smallest number among them, 1, it will change, means it will cross the limit of 20 in 5 steps only. So you can take any number, but here I've just taken the maximum number. You can change it to. That is what I got now. So you can take any number, make it a larger value than equal to 20 or greater than 20, and then change all the negatives. Because here count of negatives is less than or equal to 7, so that is a cheaper step, means it will fit in our constants of 31. The next case is count of negative, it is greater than equal to 30. Now the last cases are if count of positive and count of negative, that is less than equal to 12. So this gives us 2 cases. One is when absolute of positive is greater equal to absolute of negative, means the only absolute value. The other case is absolute of negative, it is greater than absolute of positive. So these are the cases. There are 6 cases. This is the fifth one. This is the sixth one. So these are the 6 cases. That is pretty much it for this problem. I know it might still be confusing, because for me also it took a lot of time to think about the whole thing and then find what is the correct solution. So if you still have any doubts, you can of course ask in the comment section and try to answer it as much as possible. Thank you.